We can do this on the calculator to find the exact answer. We use the normal CDF command since the distribution of x bar is normal. The lower bound is still 130, the upper bound still infinity. The mean is 100, but we need to be sure to change the standard deviation to the original standard deviation divided by the square root of n, which we saw was 3. So the answer is 7.7 times 10 to the negative 24th. Don't accidentally write 7.7 as the answer. You know probability can't be bigger than 1. And when you move the decimal 24 places to the left, we see that the calculator gives us the same thing we estimated before. The probability is basically 0. Next, we should ask ourselves, what if the original distribution had not been normal? As long as the sample size is large enough, then the central limit theorem tells us that the distribution of the sample means is still approximately normal, and we can use the normal CDF to find the probabilities. It is also good to ask, what are the most likely places to make a mistake that would cause you to miss the problem? One potential place for a mistake is if students don't read the problem closely and they miss that the problem is talking about averages. Another place for a mistake is if students forget to use the standard deviation of the sample mean, which is the original standard deviation divided by the square root of n. So try to remember that when x is normal, the probability that x is between a lower bound and an upper bound is the normal CDF, lower bound, comma, upper bound, comma, mean, comma, standard deviation. And when x bar is normal, then the probability that x bar is between the lower bound and the upper bound is just the normal CDF with lower bound, comma, upper bound, comma, mean, but be sure to use the standard deviation divided by the square root of n. Now you try it. Assume that a final exam for the Intro Stats course is moderately skewed with a mean of 70 and a standard deviation of 10. Can you use the normal CDF to find the probability that a randomly selected student scores greater than 75?